Alright, I'm going to show you how to figure out friction loss using different size hoses that we use here in the fire service. First of all, in order to figure out friction loss, you got to know what the formula is to do so. And listed in the text on page 186, you'll find this formula here. It's called C times Q squared times L. C stands for the coefficient. There's a table on page 186 that lists the coefficients. Q is the flow in gallons per minute, and then L is the length of hose. Now, in order to figure your problems up, there's a couple things I want to do so you don't. A couple things I want to tell you before you start figuring the math, so it doesn't mess you up. The coefficient, which is pretty self-explanatory, is just a number that's listed in the table. Figuring our gallons per minute, how to do that. First thing we got to do before we square that number is we got to divide it by 100. So if you've got 200 flowing 200 gallons per minute, you want to divide that by 100. It gives you 2. Simple math gives you 2. We're going to take our length of hose, which is if you got 200 feet of hose, you divide it by 100, gives you 2. Okay, so those are some things I wanted to show you first before you go and try to do your math and get frustrated. All right, I got a problem here for you, and I want to see what you come up with. So we got 1 3/4 hose flowing 200 gallons per minute at 200 feet. Okay, so I want to show you how to do this problem first, and then I'm going to put some more problems up here and see if you can do it on your own. So how you do this problem is, first of all, use the formula. That's what somebody developed the formula for, is to use it. Okay, so I've written this problem out kind of going by the formula, the way the formula goes. If you're having a hard time doing the math, what I would suggest to you to do is take the formula and write the problem out with the way the formula is written out. So what I'm saying is, these numbers may be jumbled up. So take the problem and then write the size of hose that you have, write your gallons per minute that you're flowing, and then write the length of the hose out. And then take it and do the math, how you got the problem written out. So what you do here, all right, you got 1 3/4 hose. So you look on the page 186 in your text, you look on the table, and the coefficient for 1 3/4 hose with 1.5 inch coupling is 15.5. Okay, simple right there, 15.5. Okay, all right, so we're flowing 200 gallons per minute. Okay, again, here's what we do. We take 200, divide it by 100, gives us what? 2. Okay, then here's where you got to square the number. You take 2, square 2. Okay, so 2 times itself, so 2 times 2 equals 4. So remember, when you're squaring a number, you're taking that number and multiplying it times itself. Okay, so 2 times 2 equals 4. Okay, then 200 feet. Okay, we're taking this number and we're going to divide it by 100. So we take 200 feet divided by 100, and that gives us 2. Okay, so then what we do, we take our little cheap calculator. You don't have to go out to and buy a $100 calculator to figure this up. As a matter of fact, this calculator here costs $1. As long as it has all the numbers and the buttons that you need on it, you're good. So what we're going to do is we're going to take this cheap little calculator, and we're going to take and multiply these numbers right here that are in parentheses. So we're going to take 15.5 times 4 times 2, and that gives us 124. Okay, so our friction loss for this particular problem is 124 psi. All right, now that does sound like a lot, but you got to remember, you got an 1 3/4 hose, which is one of the smaller hoses, and you're trying to get 200 gallons per minute at the end of the nozzle, and the hose is 200 feet long. Okay, so you're trying to get 200 gallons per minute out of a hose that's 200 feet long, which is size 1 3/4. Okay, so it's going to take the friction loss, just the friction loss, okay, not your total pump discharge pressure, just your friction loss is going to be 124 psi. Okay, and that seems like a lot, but you got to remember, you're trying to force a lot of water through a small hose, and you're asking this to do a lot. Okay, I want to give you this problem here, and I want you to take a couple minutes, work it, and see what you come up with. Okay, let's see if you come up with 12 psi. Okay, this is your friction loss with this formula, and how I come up with that problem is 2.5 inch hose. If you look at the coefficient, 2.5 inch hose is the coefficient is 2. 200 gallons per minute. Take 200, divide it by 100, gives me 2. I square 2, it gives me 4. Alright, so I put that number in parentheses. Take 150 feet, take 150 divided by 100 gives me 1.5. So if I take 2, multiply it times 4, multiply that times 5, 1.5, and it gives me 12.